Yeah, this feels about right. Hi everybody. So for this devlog, I worked on integrating the bowl from the last devlog into the prototype. To start off, I had to add some functionality to the server to maintain NPC state and propagate it to the client. The propagation part was easy. However, the client needs to now understand that there are different models being loaded and what to do with those. Loading the model animations is simple since I already have the infrastructure set up to do that. After that, I started researching a bit different AI techniques as I haven't programmed AI before. So first starting off with just writing it in code, which doesn't seem to scale very well. Then looking at state machines, which as we know, generally they scale exponentially when you have to add different actions. And then behavioral trees, which seem simple to implement, but they kind of seem static. And then finally, utility AI. And ultimately, that's what I went with. There are a few really great GDC videos on this. They're a bit older, but if you Google for utility AI, you'll find the two that I used. The videos talk more about theory. They show a little bit of implementation in C++, but I ended up just implementing it in a way that I found to be intuitive. The Rust ecosystem does have a library for this. I think it's called Big Brain, but it's part of a game engine called Bevy, and it looks like integrating it, I don't know, would kind of be a challenge. And also, I'm doing almost all of this from scratch, so I thought I'd implement it myself using the theory from the GDC videos. And I think one of the authors of the videos has a book out, and one day maybe I'll pick it up and read it. But for now, I think this AI works fine. In a bit, I'll talk more about the utility AI and my implementation of it. However, I generally like to show some of my struggles. Although, if I'm being honest, making this video is probably the largest struggle of this devlog. As you can see, at first when I imported into the client, I had issues with orientation and the color. And the color was simple. It was an issue with using the outdated color palette. The orientation, however, took me a little bit, but basically I forgot to zero out the rotation and the translation in Blender. So once that was done, I ended up with an issue where I could get the animations working and the orientation looked okay, but the bowl was not moving. And that had to do with the utility AI and needing some tweaking. So to start talking about the design a little bit, if you remember from the previous devlogs, the server is broken up into a few different threads that handle, for example, getting player input from the clients, which involves, parsing the UDP packets and all that good stuff. Another thread for state management for the players, and now another thread for NPC state management. So what this looks like is, just very, very simply, we have, I'll just call it PS player state coming in, and yeah, NPC state going out. And inside this thread, similar to other threads, you have a world that's maintained and also now an NPC list that's maintained. This world is being updated via these player state events that are coming in. And the reason why I did this is I didn't want to pass around a shared reference to all these threads, as then we need a locking mechanism on the world, and you can start slowing down other threads based on how many queries and things are being done to the players, for example. And it just adds quite a bit of complexity where communicating via messaging, it's a little bit behind the world, I would say, or excuse me, behind the main thread, but it works fairly well. And similarly, other threads that need a list of NPCs, for example, the main thread in this case, they can rebuild that list and keep it up to date via these NPC state events. So inside this thread, we use a ticking mechanism to do the updates. And I really like this because it gives some consistency. So for the server currently, I have it all keyed to be 20 ticks per second. And one thing that's interesting about this, and it's sort of a freebie and pretty nice. So we know the world is set up in meters. So for example, the player is about 1.2 meters tall. If you know the ticks per second, you can convert it to ticks per hour. And you can Google how fast a bull walks, which is about 2 miles per hour. And you can pretty easily get a factor that you can multiply through for the speed and get a pretty close approximation to how fast a cow walks. And surprisingly, a bull can run up to 35 miles per hour. So again, very simple calculation to get a factor for how fast a cow should run and walk. And it actually worked fairly well. So I thought that was pretty neat. And that's via using ticks. And it's also quite predictable, which I like. So for each tick on the server, we want to update the player state. And there's a couple methodologies to do that. For utility AI, the way I set it up is I have a structure called a cortex, which I know not a super original name. This cortex exists for every single NPC. And the cortex has a list of decisions, which are called Ds. And each D has one or many considerations, which are called vertices. These considerations return a normalized value, which the normalization here is the key, as it allows us to compare things like, for example, the remaining health of a player and the distance from a monster in a meaningful way. And the cool part of these considerations is before the normalized values return back to the decision, it's ran through a function. And the way that I understand it is these functions are used as a way to define the behavior of the consideration in terms of kind of the world state around it and how they overlap and compare to other considerations for other decisions. So for example, I'll do a very simple example here. Let's say we have this function here, which is an inverse linear function. And let's say it's NPC's distance to player. And let's just say this is the value. And these are between 0 and 1. Okay. So you'll see in the code that I use a range. So let's imagine the distance to the pick target returns back 0.25. So 0.25 after being run through this function here. Let's say 0.25 is here. That should be, well, that's a little off, but it should be right around here. So the value that we returned is 0.75. In layman's terms, what this means is that as the NPC gets closer to the target, this consideration and ultimately this decision has higher priority. I've only implemented a few of these functions just as a proof of concept. However, if you watch the GDC videos, you'll see that they build really awesome things. And there's so many different functions to use, and they have different meanings and different feels to the AI. And I like that a lot more when I compared it to, for example, behavioral trees, which seemed a bit more static and predictable, I would say. So if we look at the code and we start in the place where the bull is initialized, we can see quite a few properties that you would expect, position and type. And in this function, we could actually create many bulls or different NPCs and whatnot, but currently on the server, I'm just working with the one. And you'll see that we create the cortex here, and we assign it to the bull later. So the bull owns the cortex, and you'll see that the cortex has these decisions that are being loaded from this default decision map. And what that means is these default decisions can be used by other NPCs. For example, pick the target is pretty generic. So you could create many cortex of many NPCs and you could reuse this functionality. If we go down to where this map is actually built, the first thing you'll notice is it's pretty verbose and kind of hard to read. I wrote this pretty quickly, I would say. But if you notice that values are pretty static, you could probably put this in a JSON file that is loaded or created somewhere else and load it into the server. So I think that would be some future work to not have to hard code it like this, because it's kind of a sore on the eyes. And it's sometimes a little difficult to understand. For example, when I do not have a target, it has an inverse binary curve. But when I do not have a target, it's like you have to kind of think a bit of what that means. And it's a little more thinking than perhaps I would like. So anyways, we create this map with these decisions given these considerations, and each consideration has an implementation. So the considerations are an enum, so we can have all list of all the types of considerations we have in the system that's supported. And the enum is just a consideration implementation, which is also an enum. Some take a range, but I think they all take curves, if I'm not mistaken. So if we look, for example, this attack target decision, the attack target decision has a weight. So weights are nice because if you have two values between two decisions that are very close together, or maybe even both are 1, for example, this weight will offset it to give priority. So in this case, attack has the highest priority. And if we look, this has a consideration for when I have a target, and it's a binary curve. So if it has a target, then it'll be 1. And then it has when the enemy is close is the consideration, and the implementation of it is a distance to target. So again, you have a consideration, and then they can have different types of implementations for them. So distance to target is a linear curve and has a range between 0 and 7.5. If you look up here, run to target is 7.5 to 100. So between 7.5 and 100, generally speaking, this decision will be picked and they'll run to target, which has different implications on the NPC state. But down here, this range is between 0 and 7.5. And actually, as I'm looking at it, this should probably be curve inverse linear, not a linear curve. But still works. And these are little hiccups and things you have to kind of test on the server. If we look at the implementation, we can see, it's an enum here, and we need to have a match on that. So there's a little bit of ugliness. Eventually, when we calculate the value from the cortex, we have to do this match. So you kind of have a bit of redundancy, but that's kind of something you deal with Rust occasionally. So we're looking at distance to target. We have distance to target here, and just a simple distance calculation from the current selected target. And you normalize it via this range object that's given. And if the value is none, which means that it's outside the range, so we return back 0 if it can't be calculated. If not, then we throw it through the curve. So this, felt pretty nice to implement, and I think being able to extend it won't be too difficult. Anyways, this is the code. I think the next devlog I'll be working on actual collision detection and hopefully getting into implementing some sort of combat. Anyways, thank you for watching. Bye.